Hello and welcome to our brand new series here on tricky A-level maths exam questions. Now, this was a series that we did start a few years back, and for whatever reason we didn't really continue with it. I just think at the time there probably wasn't much demand. However, this is something that many of you have been asking for recently, so I think now is the perfect time to just basically start the series again, okay? And just for the final point to make here then, the questions featured throughout these videos here, so these tricky A-level maths exam questions, will be a mix of questions that we've created ourselves over here at AJMaths, as well as official past paper questions from the Edexcel specification, okay? So clearly these videos and these questions are aimed at Edexcel students, but that isn't to say that if you're studying, say, AQA or OCR, that you won't find any value within these videos here, okay? So I think at this point here then, there isn't really much else that I can say or add to the series as a whole. It's pretty straightforward, right? We're just going to answer some tricky A-level maths exam questions. But before we get started with today's question then, just a quick word from our sponsors, which is ourselves. That's right, in less than a minute here, I want to quickly show you why you should be using ajmaths.co.uk to help boost your A-level maths revision. So as you can see here then, we have an example page from our website based on quadratics. So each page here starts in a similar fashion. We start with a brief description of the topic, as well as what you'll be able to do after watching the AJMaths revision videos for that topic. As you can see here then, once we scroll down, we have each of the videos in order. So for example then, completing the square, the discriminant, trickier examples for the discriminant, so on and so on. Now once you watch all of the revision videos here, we have worksheets for you to attempt. So we have a worksheet here on quadratic modeling, as well as exam revision for quadratics. And this also includes full solutions here. And what I am also in the process of adding here is our A-star questions for each topic. So keep an eye out for those. They'll be coming very, very shortly. And then finally here, for each topic, we have the previous topic and the next topic, just to make your revision and your life a little bit easier here as you prepare for quite a stressful time studying your A-level maths exams. But there we have it then. So thanks for your time and back to the question. So let's just get started here then with the very first question in our brand new series on tricky A-level maths exam questions. Now, as we can see then for this question here, we have a rectangle that has a perimeter of 10 root 3 centimeters and an area of 12 centimeters squared. It then says, given your answers as surds in their simplest form, find the dimensions of the rectangle. Now, to get us started here then with the very first question in this series, or day one, however you want to think of it, I've started with a bit of an easier topic. So this is obviously algebraic expressions and more specifically surds. So it's going to be easier than, say, differentiation, integration, vectors, so on and so on. But compared to your typical A-level maths algebraic expressions question, this will be a lot more challenging, okay? So where do I actually begin here then with this question? Well, let's just think about drawing a rectangle here. Let's just say something like this, okay? Clearly, those should be straight lines, but we'll just roll with it. So let's say that we don't know the dimensions here, right? That's what we're looking to find, the dimensions of the rectangle. So let's just take this one here as x and this one here as y, okay? Now we know then that the area here, so the area of this rectangle here will be xy. So the area is xy, but we know then that the area here of this rectangle is 12 centimeters squared. So xy then is equal to 12. And then for the perimeter here, so for the perimeter here, let's just write this down in full. This would be x plus x here plus y plus y. So basically just 2x plus 2y, okay? And we also know then that the perimeter here, 2x plus 2y, is equal to 10 root 3, okay? So that's 10 root 3 there, okay? So what I've done here then is just form simultaneous equations, right? I've got equation 1 here. Let's just label that as equation 1. And I've got this equation here, equation 2, okay? Now what I'm going to do then is rearrange here equation 2 into either x or y as the subject, and then substitute that into equation 1, okay? So what I'm going to do here then is rearrange equation 2 and make y the subject, okay? So at this point here again, should be pretty straightforward. So I get 2y. So 2y is equal to 10 root 3. So 10 root 3 minus 2x And then finally, we just want y as the subject here. Just divide both sides by 2, right? And in that case, then what we get here is y is equal to 5 root 3. So we get 5 root 3 minus x there. Okay. And as we just said, then all we're going to do here is now substitute y into equation 1. Okay. So I'm just kind of highlight this here then in a different color. Let's just substitute this now into equation 1. Okay. Going back to my original pen color here then. So what would we get here? Well, this is xy is equal to 12. So what I get then is x times by y here, which is 5 root 3 minus x, right? So I've got x times 5 root 3 minus x there, like so. And this here then is equal to 12. Okay. So now let's just expand here this single bracket and the term on the outside then. So I've got x times 5 root 3. So that's 5 root 3 x here, like so. And I've also got x times minus x here. Just be careful your signs right. That's minus x squared. So we get minus x squared there. And again, all of this here is equal to 12. Okay. Now clearly, what we're going to obtain here then is a quadratic equation. Or what we have obtained, I should say, is a quadratic equation. But what I want to do here is make one side of this quadratic equation 0, right? And hopefully solve for x then. Okay, because we're looking to find the dimensions of this rectangle here. So clearly we need to find x and also y. Okay. So given that this is minus x squared here, well, we don't really want to work with minus x squared. So let's just add x squared to both sides. And let's also just subtract 5 root 3x off both sides as well. Okay. So if we do that underneath here, then we get x squared. So x squared minus 5 root 3x minus 5 root 3x here plus 12 is equal to 0. Okay. Now I'm hoping it's obvious, but this quadratic equation here will not factorize. So we need to employ a different method then to solve this quadratic, right? So we could complete the square, but I wouldn't personally recommend it given that this b term here is 5 root 3. Things start to get a little bit messy. So what I would do here then is just use the quadratic formula. Okay. So let's just do this underneath here. So we're solving for x here then. So x is equal to, so I get minus b, so that's minus 5 root 3. So that's just 5 root 3, right? 5 root 3 plus or minus, so plus or minus the square root then. So what else do we get here? So I get b squared, so that's 5 root 3 squared. So I'm just going to write this out without simplifying just yet, just to make life a little bit easier. So I've got 5 root 3 all squared minus them. So I've got 4 times by a, which is 1, times by c, which is 12. I've got 4 times 1 times 12. Okay. Like so. And all of this here then is over 2a. So that's 2 times 1, which is 2. Okay. So let's just keep simplifying here then. So what have I got here? So I've got 5 root 3. Can't do anything with that currently. Plus or minus them. We get plus or minus the square root here. So what do we get underneath here then? The square root. So 5 root 3 squared, that's going to be 5 times 5, which is 25. Times that by 3, so that's 75. I get 75 there. Minus then 4 times 12, so that's 48. So 75 minus 48 here. And again, that's all over 2. So 75 minus 48 here, that gives me 27. So what I've got here then is 5 root 3. So 5 root 3 plus or minus the square root then of 27 all over 2. Well, let's just simplify this third here then. So root 27, we can rewrite that, right? So let me just do that at the top here. So root 27, that's just the same as root 9 root 3. Root 9 root 3. Root 9 is 3. So what I get here then is 3 root 3. Okay. So I've got 5 root 3. So 5 root 3 plus or minus 3 root 3. And all of this here then is over 2. Okay. So this is for x here. So in that case then, x here will either be equal to 5 root 3 plus 3 root 3 over 2. So that's 8 root 3 over 2, which is 4 root 3. So let me just write the solutions over here then. So therefore x is equal to, so as we just said then, 8 root 3 over 2, which is 4 root 3. We get 4 root 3 there. It's supposed to be a 4. Let me just quickly redo it. Just because we do like perfection here, we can, achieve it. So 4 root 3, there we go, 4 root 3. And then if we account for the negative solution here, so 5 root 3 minus 3 root 3, that gives us 2 root 3. Divide that by 2, right? And we just get root 3 there. Okay. So x equals 4 root 3 or x equals root 3. Okay. And now for the y solution then, well, all we need to do here is just substitute that into either of the other two equations here, either equation 1 or equation 2. Okay. So when x is equal to 4 root 3 here, now I am kind of running out of room. I don't want to clear the screen just for the final bit of the solution here. So let me just kind of continue over on the left-hand side. So when x equals 4 root 3, so when x equals 4 root 3 here, then y is equal to, well, let's actually just use this rearranged form here, right? Y equals 5 root 3 minus x. So in that case, then what I get here is 5 root 3 minus 4 root 3, which is simply root 3. Okay, so when x equals 4 root 3, y is equal to root 3. And then hopefully you can spot what's going to happen here then with the other x solution. So when x equals root 3, in that case then y is equal to, so we get 5 root 3 minus root 3, which just gives us 4 root 3. Okay, so 4 root 3 there. Okay, so let me just quickly highlight the solutions here in different colors. I've got this solution here and this solution here. So to finish with them, the dimensions here, so the dimensions of the rectangle, that's supposed to be an S, the dimensions of the rectangle are given as, so we have root 3, that's root 3 centimeters, don't forget the units as well, and also 4 root 3. And again, don't forget your units, okay? And there we have it then. So that gives us the solution to the very first question here in our brand new series on tricky A-level maths exam questions. As always, thanks for watching.